Welcome to Process Protocoll, where we explore groundbreaking industrial technologies transforming the way the world produces and moves goods. Today, we're diving into a fascinating and rapidly evolving field, hypersonic logistics. Imagine a world where goods travel faster than ever before at speeds greater than Mach 5 or more than 5 times the speed of sound. This ultra-fast industrial transport technology is poised to fundamentally reshape global supply chains, slashing delivery times from days or weeks to mere hours. But what exactly is hypersonic logistics? And what engineering breakthroughs are making this possible? In this video, we'll dissect the cutting-edge science behind hypersonic vehicles, the massive infrastructure changes needed to support them, and the profound impact this will have on global commerce and industries worldwide. So, what is hypersonic logistics, really? It refers to the transportation of goods at speeds exceeding Mach 5. To give you some perspective, that's roughly 6,000 kilometers per hour, or about 3,700 miles per hour. Your typical commercial airliner cruises at around Mach 0.85, so we're talking about a genuine quantum leap in speed. This term, which used to be reserved for military and aerospace talk, is now being adapted for industrial use. The idea is to move cargo, not missiles or spacecraft. We're talking about everything from critical medical supplies and high-value electronics to everyday consumer goods, all zipping across continents in a matter of hours. This incredible speed is set to challenge the very foundations of our global supply chains. Right now, shipping goods across oceans can take weeks. Even air freight, the fastest option we have, can take a day or more when you factor in all the logistics. Hypersonic transport promises to shrink these timelines dramatically. Imagine ordering a specialized part from a factory in Germany and having it arrive in New York the same afternoon. This would make our supply chains incredibly responsive and resilient, able to adapt to disruptions almost instantly. It's not just about making things faster. It's about making our entire system of production and delivery smarter and more robust. The potential here is absolutely huge. Now, achieving and sustaining these incredible speeds is no small feat. It requires solving some massive engineering challenges. First up is thermal protection. When you're flying at Mach 5 or faster, the friction with the air generates intense heat, sometimes exceeding 1,000 degrees Celsius. To survive these temperatures, hypersonic vehicles need to be built with advanced heat-resistant materials. Think carbon composites or special ceramics, similar to what you'd find on a space shuttle. Without this protection, the vehicle would simply burn up in the atmosphere. It is a bit like designing a thermos flask that can fly at thousands of miles per hour. Then there's the engine. Traditional jet engines, like the ones on the plane you fly for vacation, just don't work well at hypersonic speeds. They can't handle the airflow. So, engineers are developing scramjets, which stands for supersonic combustion ramjets. These are amazing pieces of technology. Scramjets are a type of air-breathing engine that compresses incoming air at supersonic speeds before combustion, allowing them to generate efficient thrust at hypersonic velocities. Unlike a rocket, they don't need to carry their own oxygen, which makes them lighter and more efficient for flying within the atmosphere. Aerodynamics also becomes a whole new ballgame. At these speeds, the air behaves differently. Hypersonic vehicles need incredibly sleek, optimized shapes to cut through the air with minimal drag and maintain stability. We're talking about slender, wedge-shaped bodies and specialized control surfaces that can make tiny adjustments in extreme airflow conditions. It's a delicate balancing act between speed, stability, and control. And finally, you have guidance and navigation. Traveling at over a mile per second requires incredibly advanced real-time navigation and control systems. These systems have to process vast amounts of data to safely maneuver through changing atmospheric conditions and avoid any potential obstacles. Leading aerospace companies and government agencies are pouring billions into this research. We've already seen successful prototypes, like NASA's X-43A, which set a world speed record at Mach 9.6, proving that scramjet-powered flight is not just science fiction. Of course, having these amazing vehicles is only half the battle. To actually use hypersonic logistics on a global scale, our infrastructure will need a major overhaul. For starters, we'll need new kinds of launch and landing facilities. Unlike traditional planes, these hypersonic cargo vehicles might require specialized launch pads almost like rockets or extra-long high-speed runways. Some concepts even involve air launch systems, where a conventional aircraft carries the hypersonic vehicle to a high altitude before releasing it. Then, you have to think about what happens on the ground. The supply chain hubs will need to operate at lightning speed to keep up. We'll need highly automated, AI-driven logistics centers that can manage the flow of goods, load and unload cargo in minutes, and integrate seamlessly with the hypersonic flight schedules. If the vehicle can cross the Atlantic in 90 minutes, you can't have the cargo sitting in a warehouse for hours waiting to be sorted. Every part of the process has to be accelerated. And let's not forget the rules and regulations. Hypersonic cargo flights will be crossing multiple countries and different airspaces at incredible speeds. This will require a whole new set of international agreements and safety protocols to coordinate these operations and manage any risks. We'll need a global air traffic control system for the upper atmosphere. Plus, there are energy and environmental considerations. While speed is great, we have to balance it with fuel consumption and emissions. A lot of ongoing research is focused on developing sustainable fuels and making these propulsion systems as efficient as possible to minimize their environmental impact. So, what does all this mean for global industries and our supply chains? The impact will be massive, rippling across almost every sector. The most obvious benefit is speed and responsiveness. Just-in-time manufacturing and retail models, which rely on getting parts and products exactly when they're needed, will get a huge boost. Companies will be able to respond almost instantly to shifts in consumer demand or unexpected supply disruptions, which means less money tied up in inventory and less waste overall. This also opens the door to entirely new business models. Imagine on-demand manufacturing where a custom product is made and shipped to you from anywhere in the world in less than a day. Or think about delivering ultra-fresh, high-value food like seafood or exotic fruits across continents while they're still at peak quality. In emergencies like natural disasters or medical crises, hypersonic logistics could be a lifesaver, rapidly deploying critical supplies and equipment to wherever they're needed most. It could fundamentally change how we think about distance. Interestingly, while it supports global trade, hypersonic logistics might also encourage a new kind of localized manufacturing. Companies could keep their production hubs spread out but use ultra-fast shipping to bring components together as needed. This creates a balance between the efficiency of a global supply chain and the resilience of a local one. And of course, being an early adopter of this technology will give companies a huge competitive advantage. Those who can master this new level of supply chain agility will be able to offer faster delivery and better service, winning over customers and dominating their markets. Now, despite all this incredible promise, it's important to be realistic. Hypersonic logistics still faces some significant hurdles. The development and operational costs are currently very high, which will likely limit its use in the early days to high-value or time-critical goods. You probably won't be getting your new socks delivered hypersonically anytime soon. There are also safety concerns, especially around the sonic booms that occur when traveling over populated areas. And as we mentioned, the environmental impact and fuel efficiency are challenges that still need to be fully solved. However, the progress we're seeing in materials science, propulsion technology, and AI-driven logistics management is incredibly encouraging. It suggests that these challenges are not insurmountable. Hypersonic logistics is no longer a distant dream or something you only see in movies. It's rapidly becoming the next frontier in industrial transport, and the groundwork is being laid today. Thanks for joining us on this deep dive into hypersonic logistics, a technology set to revolutionize how goods move across the globe at ultra-fast speeds. If you enjoyed this exploration of the future, please give this video a like, subscribe to Process Protocoll, and hit that notification bell so don't miss our next update on industrial tech and supply chain innovation. What are your thoughts on hypersonic transport? Do you think it will change the future of global commerce? Let us know what you think down in the comments below. This is Process Protocoll, where the future of production and logistics unfolds. We'll see you in the next video.